Welcome back. Today we're gonna cover creating parallel curves in this video. All right, so how to create parallel curves. Okay, go ahead and download the file here from the site or from the zipped folder that I emailed you. Don't forget to unzip the folder, extract all. That way later on when you save your work, it doesn't give you some type of error message. All right, so let's go ahead and download parallel curves, and I'm going to go ahead and open it. Okay, so once again, I'm going to change the colors. Don't like the colors here. And I'm going to change the lines and the points. Okay, I was not able to change the lines because they have their own color. So if I wanted to change the color of these existing lines, I would have to right click and go to properties, and I would have to change it from here. So even though the GeoSet has a color, whoever made up this, the user who made this tutorial assigned individual colors to it by just simply right clicking, properties, and changing the color individually, separate from the GeoSet. All right, so let's go ahead and insert our own GeoSet. Okay, and I'm going to give it some color. Okay, so what we're going to do in this tutorial is we're going to basically we're going to translate curves, but it's going to be a constant offset. All right, so let's go to the tutorial. Okay, so we're going to use parallel curve. So we're going to be translating this arc, appears to be an arc, and we're going to translate it. And we'll do it onto a support. Again, a support is a plane, a surface, or it can even be a line. Okay, so let's start by doing parallel using 2 millimeters on this surface. Okay, so let's go back to CATIA. Okay, so we're going to take this line or this curve, and we're going to do an offset using the parallel command, and we're going to pick the surface as our support. Okay, so let's go ahead and do that. Okay, so parallel curve, I'm going to click on it. Okay, I'm going to select my curve. All right, so let's go ahead and get a preview, see if it'll give us a preview. Yes, it's already given us a preview. As you can see. Okay, and I'm going to hit OK. And there it is. There's our parallel curve. Notice it takes on the name of the command. So the command is parallel curve, and it gave it the name parallel. They left out the curve part, but that's okay. All right, so even though this is an arc, it looks polygonal, right? It almost looks like an octagon shape. And the reason it looks like this, it's because if it tries to make this curve look as circular as possible, it's going to eat up a lot of memory. So one of the things about CATIA in the settings, if it's trying to create a perfect arc or circle, then you need more points. The more points it tries to generate to give you that perfect circular shape, the more memory it eats up, the more it slows down your computer. Anytime you rotate, it's eating up a lot of memory as you rotate and move things around, and it's trying to keep up with your rotation or panning. So it's trying to graphically keep up with you, and it may slow down your computer. There is a fix to this. If you want to smooth this out, even give you a cleaner curve and not a polygonal sharp looking curve, you can always go to Tools Options, I don't recommend you do this unless you have a very powerful computer with a strong graphics card. You can go to Tools Options. And we're going to go to Performance. Let's go to General, Display, and Performance. So go to General, Display, Performance. And this is where you can control it. Okay, so not only will it clean up the curve, make it look more round, but also it'll clean it up as you're rotating. So you have the option of it quickly updating as it's graphically updating as you pan or as you rotate the object. You can slide these, but again, it's gonna slow down your computer, right? So, hey, do you want it to regenerate that nice arc as you're rotating it while you're moving it, right? Or while it's static when you're not panning or zooming in or out. So while moving, that includes zooming in and out, rotating, panning, or when it's static, you're not making any translations, rotations. So you can control how more accurate you want it by picking proportional and then sliding the bar. But the more you increase it, the more it's going to slow down your computer, but it'll look cleaner once you make the changes, change the accuracy. If you improve on the accuracy once again, I'm not going to do it. It'll clean this up, make it look a lot more rounder. But I'm going to leave that alone. Okay, because I don't want to slow down my computer. It's already slow as it is. All right, so let's go back to parallel. I'm going to double click. So we did a 2mm offset. Okay, we can also offset up to a point. So it's hard to see, but there's a point here on the surface. If you don't see it, we're going to pick this point. So I'm going to go to the point option. So instead of giving it a 2mm constant offset, I'm going to go to point. I'm going to select this point. I know it's hard to see. It's point number 10. So in the geo set, point number 10. Okay, so I'm going to hit preview and it does an offset up to that point. As you can see, again, see how it's slightly off. It's our performance graphically, it's not a good representation. It's just jagging the curve just so it doesn't eat up a lot of memory. But that curve is on that point. Okay, so instead of typing in a number, you can say, hey, I want to go up to a point, and notice how the 2mm is grayed out. It's ignoring it. Okay, you also have the option of going geodesically or Euclidean. It's not going to make a difference here because it's a flat surface. If it's a curved surface, you'll see a difference between a Euclidean offset versus a geodesic, but it has to be on a curved surface. Also, even though we did an offset and it appears to be on the brown surface, it doesn't guarantee it's on the surface. So just to make sure it is on the brown surface, we can pick support. Say, hey, when it offsets, I want to make sure it projects onto the brown surface. Okay, so there it is. So fill 1 is the brown surface. Later on, we're going to be using the fill command in the next class session. Okay, and preview. Okay, so now it did offset and it guarantees that it's on the brown surface. All right, so also we have sharp and round. We're going to demonstrate this with one of the other elements in a few minutes. And let's go back and remove the point. Let's say I wanted to do a 2mm constant offset. I'm going to remove the point. I'm going to right click and clear selection. It goes back to 2mm. Let me go down to 1mm and preview. And I can switch direction, as you can see. Preview, reverse it. I can say, hey, I want to go 1mm constant offset in both directions, as you can see. You can repeat if you want to do multiple, right? If you want to do multiple, you can say repeat and it'll create a bunch of them. Okay, if you want to play with that, go ahead. I'm just going to leave it alone. And I'm going to hit OK. All right. Let's continue on with this tutorial. Ah, law. Okay. We have this option called law, L-A-W. Laws are awesome. They're a little difficult to understand. And let me show you where I've used laws before. So when I was doing some electrical design work, and we want to cover the electrical wiring in a car with these corrugated plastic tubes. You can find these at any hardware store or auto parts store. So to protect the electrical wiring in the car from it getting scratched or dinged or the plastic coming off the wire, right? You can cover it and protect them with these corrugated tubes. So when we had to model these corrugated tubes, sometimes you want to change the distance, the offset between the ribs, right? Or maybe you want it to taper. Maybe you want to use a larger diameter on one end and a smaller diameter on the other end. And you can taper it. Okay, and we would use a law command. Law can also be used to taper an existing sketch, for example, or an existing curve. So let's go ahead and do a simple law operation. Okay, so we're going to go back to the line we just created, the parallel line, and we're going to apply a law. It's pretty cool. Let's go back. Okay, so let's go back to our parallel. Notice it created two because it went in the opposite direction and created a second one. So let's go back to our parallel. Double click. All right, so we're going to apply a law. So here's the law button. So currently we have a 1 millimeter offset, constant all the way throughout. Let's go to law. And I'm going to say, by the way, there's a bunch of different ways you can define a law. You can use like cosine, sine waves. I'm not going to get into that till later on. All right, so I'm going to go with the linear offset, which is going to taper. So I'm going to go linear. Okay, and I'm going to say, hey, I want the first offset to be 1. I want the second offset to be 0. So I want it to offset here by 1 unit, and then I want it to taper down to 0. Okay, so I'm going to hit close. I'm going to hit preview, and don't blink in 3, 2, 1, preview. Oh, you blinked, see? It tapered from 1 down to 0. That's pretty cool. Okay, let's go back to the law. Okay, let me increase it from 1 to 2 and leave the other one at 0. See if it's not too much. Close. Preview. Okay, so it starts with the law of 2. So there's an offset of 2, and then it tapers down to 0. You don't have to taper it down to 0. Let's go back to law. Okay, and say, hey, my linear offset for my endpoint, instead of 0, I'm going to go to 1. And close. And preview. Okay, so it goes from 2, and it tapers down to 1. Okay, and it's a constant taper. All right, so hit OK. And that's what it looks like. That's pretty cool. And going back to the corrugated, and later on, as a demo towards the end of the semester, I'll show you how I created a corrugated tube. Basically, you have to use a curve and a sketch. You have to use it can be two different sketches to create your corrugated tube. You'll create a sketch to create the tube and a second sketch to make it corrugate. All right. I don't know if that's the right term, corrugate, but that's where and I'll demonstrate it later on. Okay, so let's continue on with the tutorial. Okay, so now we're going to do a parallel with this line. And we're going to get two different results. So we're actually going to offset outward. We'll take this line and offset outward using parallel. Okay, so let's go back. Okay, so we're going to take this line that we see here. Let me change the color. I'll make their color green. So I need to go to the local level, right? So I just click on it, go to right-click properties, apply, okay. There it is, green. All right, so we're going to do a parallel on this line. Let me look at it from the X direction. There it is. Ta-da! See how you can click on the axes and it'll go normal to the axis that you select. So you can see. Okay, pretty cool. Okay, so this would be the x-axis. There it is. Okay, so we're going to do a parallel on the sharp element. So we have a sharp corner here. It's not a smooth curve like the previous one. Okay, so let's do parallel once again. Parallel. And we'll select this line. And let's go in the reverse direction. We're going to go outward, just like in the tutorial. Again, you don't have to follow the tutorial exactly. You know, if you want to play around, do different numbers, different options, go for it. Have fun. All right, so let's go ahead and preview, see what we're going to get. So that's going to be the result. Okay. So let's say, you know what, I wanted to do an offset, but I wanted to round off this corner. So it's a continuous offset. So right now this offset is 2 millimeters. So from here, I want to offset 2 millimeters radially. Okay, so we have the option, instead of sharp, we can say, hey, we want this to be round. And in 3, 2, 1, preview, see, it rounds it off. Once again, this is supposed to be a nice arc, but it turns it into a polygon, so it doesn't slow down your computer and eat up a lot of memory. And preview. Okay, if we're happy with it, hit OK. And there's our clean looking curve, right? Okay, sometimes you want to smooth things out. So if I go back, double click on it, you do have this smoothing option. Sometimes you don't get a nice, clean, continuous curvature curve or surface. So you can always play around with the smoothing. Say, hey, I want this to stay smooth. I don't want any sharp corners. You can go to tangent, curvature. Let me go back to sharp corner. Okay, I'm going to go back to sharp corner. Preview. And then I'm going to come back and smooth it out. Let me hit OK. I want to show you something. This is a sharp corner. Let me change the thickness because I should be able to see a little white dot. Let me change the thickness down to 1. Hard to see, but there's a little white dot. So that tells me there's a sharp corner or it's a tangency point. If I want to smooth this out to get rid of that point, I can use the smoothing option. So I'm going to double click and say, hey, that sharp corner, I just want to smooth it out a little bit. I can pick tangency option. And I can go with 3D smoothing. In this case, it's planar, this curve, so we don't need 3D smoothing. If it was curved, notice it's flat from this perspective, you can see. If it was curving inward in the X direction or outward, then 3D smoothing would help us. So we don't need to turn on that option for this example. Okay, so hit preview and OK. And it still didn't clean it up, so I can go to the next level, curvature. So let's go back, double click. Okay, tangency didn't do much for me, so let's go to curvature. So I'm trying to get rid of that little white dot, letting me know it's not curvature continuous. And preview. And OK. And it still didn't clean it up like I wanted it to. Double click again. Let's see if I can do anything with 3D smoothing. And let me increase the deviation. Let's see if there's a limit. There's a max. Let me try 0.1, see if it accepts it. And preview and OK. And it still didn't clean it. Huh? Don't I look ignorant? All right, so this was not a good example for smoothing. So ignore what I've said in the last minute. Later on, we are going to have a lecture on curvature continuity, and it's important. Those of you that decide to work in a automotive car studio with the clay models, smoothing is very important. Also, if you're going to work with aerodynamicists, where you have to create the curves, for example, for a fuselage and generate a surface. Okay, so I'm going to leave this alone instead of going in circles trying to fix this. All right, so let's go back to the tutorial. And I think we already have gone through everything. Okay, we did cover that area. It does bring up smoothing. And once again, the smoothing, you're trying to get rid of these little white dots. Now, this is not in our example, but this geometry. Oh, actually, there it is. I missed it. Parallels. Missed it on the previous video too. Let's open this one up. Okay, so I thought we were done. Hey, it turns out there's a smoothing one. Here it is. Open file. Okay, there we go. All right, so let me change the color of the surface. Let's see, where's the surface? It's this one. Properties. And I'm going to change it to a dark color so we can see it. Okay, and there's a line there. Let me change the color. It's hard to see. Okay, so we have this line. And it's an intersect between the surface and this plane. See how I double clicked and it's telling me, hey, this is the result. This green line is a result of intersecting the surface with the plane, which is plane number 1. As you can see, you can always right click and say, hey, take me to that plane. Right click, center graph, and it centers it with respect to the screen. Here's the center. Look at the vertical of your screen. Go to the halfway point of the vertical, and there's the plane 1. Okay, so let me cancel and turn on that plane. There's that plane. If I was to double click and move it, see it's intersecting the plane and the surface, and the green line is the result. Okay, so we're going to try and clean up this curve. So I go to intersect. So earlier we did go over an intersect video, and I missed this file. I saw it, but I missed the CAD part file. Okay, so I'm going to double click on intersect. And I should have a smoothing option here. Oh, don't have a smoothing option. Okay, cancel. That's okay because we do have a smoothing command. Okay, so let me intersect it myself from scratch. See if I get the smoothing option. Intersect, surface with line. And I was hoping it would give me the smooth option. It's not giving it to me. Okay, so that's okay. We do have a smoothing option right here. And we'll talk more about this later on. Curve smooth. I use this a lot when working with Class A surfaces for automotive or even for aerodynamic surface on aircraft. So curve smooth. Okay, I want to smooth this curve and get rid of those little white dots. See how it's telling me, hey, those little white dots, you don't have curvature continuity. Okay, it's discontinuous. And the reason it's giving me those little dots is because the surface is not smooth. It's not a curvature continuous surface. It's, you can see 4 different patches. 1, 2, 3, 4 patches. So I can say, hey, I want to smooth this out. The best one is curvature. Okay, let me hit preview and it'll let me know if it smooths it out. Preview. And it says, yes, it's erased those little white dots and it's smoothed out. Okay, so imagine you have a sharp corner and you're trying to rub out that sharp corner. Imagine you're working with metal. Or with, let's say you're working with clay and the edges are sharp and you can either push on it or use a tool to push on it to smooth it out. Just like, for example, in boxing, when you have a fighter with the big knot on their forehead on the side of their eye and the cut man or cut woman takes that little tool, looks like it's made out of aluminum, and they just push on that knot to try and smooth that out, right? Same idea. We're trying to smooth out the curve to take out any kinks on it. Okay, so let's hit preview and okay, and the white dots are gone. It smoothed it out. Okay, so that's smoothing. Okay, if we go back to the other CAD part, let's go back to the parallel curves. So I was not able to get rid of that point. Let me see if I can do it with smooth. Maybe it's too sharp. So let's try it again. See, letting me know, hey, this corner is sharp. If you want to smooth it off, round it off. Again, imagine you're doing some woodwork, working with clay, and you're trying to round off this corner with the tool or by pushing it by hand with your palm. Yeah, I want to make it a curvature continuous. Preview. And it says, hey, it erased that sharp corner, that vertex. Okay, and okay. And that white dot is gone. Okay, so what it's doing, it's trying to smooth it out. I can zoom in more. As you can see, there's no longer a sharp corner. Even this looks like a straight line, it actually is round. Again, because of my graphics card or my performance. This is rounded off, and it's cleaning up that sharp corner. Okay, so that is smoothing, and we'll talk more about that when we discuss curvature continuity. I'm going to dedicate a whole lecture just to curvature continuity. All right, so we're done with this video, and I'll see you in the next video. Don't forget to save your work, file, save as, use your initials or type in complete, save it on your flash drive or desktop folder. And once again, a reminder, I'm uploading all these files into the YouTube channel. So once you gone through one tutorial, hey, take a look at the next video. All right, see you in the next one.